Imagine two of the most extreme objects in the universe, neutron stars locked in a death spiral. Each one is no bigger than a city, yet heavier than our sun. As they collide, space itself shudders. The explosion they unleash, called a kilonova, outshines entire galaxies and releases more energy in seconds than billions of nuclear weapons could in all of human history. Now, imagine humanity trying to harness that energy. Could we? Should we? And what would it mean if we did? For centuries, humans have been obsessed with energy. Fire gave us survival. Coal gave us industry. Nuclear power gave us near limitless potential. And now, as we look to the stars, we ask the ultimate question. What if we could control the energy of a cosmic explosion itself? Join me as I dive into the mind-bending challenge of figuring out what would happen if humanity tried to harness the incredible power of a kilonova. Imagine a cosmic event so powerful that it outshines an entire galaxy for a brief moment. This is what happens in a kilonova, an explosion that occurs when two neutron stars or a neutron star and a black hole merge. The energy released in such an event is immense, and scientists estimate it could be 1,000 times more powerful than a supernova. Harnessing this power would be a game changer for humanity, providing a source of energy that's virtually limitless. A kilonova, ISNT, just an explosion. It's an event so powerful that our current understanding of physics struggles to capture its scale. The sun produces about 400 trillion watts of energy every second. That's more energetic than humanity could ever use in a billion years. Yet a kilonova can unleash 1,000 times more. In an instant.
In 2017, astronomers detected the light from a kilonova 130 million light-years away.
Even at that distance, our detectors shook with the signal. Now imagine the raw power up close, an energy source so vast it could power civilizations for millions of years. The primary challenge humanity faces in attempting to harness the energy of a kilonova is our current technological limitations. We're talking about an event that releases energy in a matter of seconds, and we need to figure out how to capture and convert that energy into something usable. The risks are also astronomical, literally. If we get it wrong, we could be facing a catastrophe that's hard to even imagine. The safety of our planet and our very existence is at stake. Humanity's story is the story of energy. Fire turned night into day. Steam engines fueled empires. Electricity wired our cities together. And nuclear fission promised unlimited energy, though at terrible risk. Each time, we reached higher. Each time, the cost grew. Harnessing a kilonova would be the next and final step. It would move us up the Kardashev scale from a Type 1 civilization using planetary power to a Type 3 civilization capable of manipulating galactic energy. In essence, we would leap from fragile earthlings to cosmic gods. Another challenge is the distance and accessibility of kilonovas. These events are rare and usually happen in distant galaxies. We'd need to develop technology that can travel to these galaxies or find a way to harness the energy from a kilonova that's much closer to home. The engineering and physics challenges are daunting, to say the least. We're talking about materials that can withstand extreme temperatures and radiation, and systems that can efficiently convert the energy into a usable form. But here lies the temptation. With such power, humanity could do anything. We could terraform Mars in a single generation. We could light up entire cities with the energy from a single blast. We could build starships that travel between galaxies. But history teaches us something darker. Every time we unlock a new source of power, we also unlock new risks. Fire burns. Nuclear power devastates. And kilonova energy might not just destroy us, it could unravel the very balance of our galaxy. The theoretical frameworks for harnessing kilonova energy are still in their infancy. Scientists have proposed a few ideas, such as using magnetic fields to capture the energy or developing advanced materials that can withstand the extreme conditions. However, these ideas are still purely theoretical, and we need to invest significant resources into research and development to make them a reality. Before humanity can dream of harnessing a kilonova, we have to understand what it really is. Because this isn't just another explosion. It's not a supernova, not a black hole, not something our minds were ever designed to comprehend. A kilonova begins with two neutron stars. Each one is the crushed core of a once massive star that died in a supernova. Imagine our sun collapsing until it was only 20 kilometers across, smaller than a single city, but still holding the sun's entire mass. That's a neutron star. Now put two of these monsters in orbit around each other. Slowly, over millions of years, they spiral closer and closer, dragged inward by the invisible pull of gravitational waves. And then they collide. Kilonovas are incredibly rare events, but when they do happen, they release an enormous amount of energy across the electromagnetic spectrum. This energy is released in the form of gamma rays, X-rays, and even gravitational waves. To tap into this energy, we'd need to develop technology that can detect and collect these signals. The scientific community has made significant progress in detecting gravitational waves, for example, but we're still far from being able to harness them. When neutron stars finally meet, the violence is beyond imagination. Their combined mass is crushed, twisted, and blasted outward in a fireball brighter than galaxies. Temperatures soar to billions of degrees. The collision creates gravitational waves that ripple through the universe, distortions in space-time itself. It also sends out a blinding flash of gamma rays, X-rays, and visible light. For a brief moment, the cosmos becomes a fireworks show of creation and destruction. How powerful is this explosion? Let's compare. The most powerful nuclear weapon ever detonated on Earth, the Tsar Bomba, released about 50 megatons of energy. A supernova releases the energy of billions of such bombs every second. Kilonova! It dwarfs even supernovas. In less than 2 seconds, a kilonova can release more energy than our sun will produce over its entire 10 billion year lifetime. This not just power, it's cosmic overkill. And humanity, for all our ambition, has never attempted to tame something even a fraction of this scale. The formation of kilonovas is a complex process that involves the merger of two incredibly dense objects. This merger creates a massive amount of energy that's released in a very short period. Scientists have been studying kilonovas using simulations and observations, trying to understand the underlying physics. By understanding how kilonovas form and evolve, we might be able to find ways to tap into their energy. But raw power comes with deadly baggage. Kilonovas unleash gamma ray bursts, jets of invisible energy so destructive they could sterilize entire planets. If one were pointed at Earth from within our own galaxy, the ozone layer would be destroyed in seconds. Crops would fail. Oceans would die. Humanity might not survive. So the first question is this: could we even approach a kilonova safely enough to try harnessing it? In a breakthrough moment, scientists propose a new technology that could potentially harness kilonova energy. This technology uses advanced materials and artificial intelligence to detect and collect the energy released during The idea is still speculative, but it's an exciting glimpse into what the future might hold. Imagine a spacecraft that can travel to a kilonova and collect the energy, beaming it back to Earth as a clean and virtually limitless source of power. And this is the paradox. To harness a kilonova, we'd need to get close enough to capture its power. But to get close enough is to risk annihilation. Yet humanity has always been drawn to the impossible. We dared to split the atom when we knew it could destroy us. We dared to explore space when it could kill us. And perhaps one day we'll dare to stand in the blast zone of a cosmic explosion. The implications of harnessing kilonova energy are profound. It could provide a solution to our energy crisis, enabling us to power our civilization without relying on fossil fuels. It could also enable us to explore the universe without worrying about running out of energy. The possibilities are endless, and it's an exciting area of research that could change the course of human history. As we explore the possibility of harnessing kilonova energy, let's not forget the challenges and risks involved. We need to approach this with caution and carefully consider the implications of our actions. The stakes are high, but the potential reward is worth it. In conclusion, harnessing the power of a kilonova is a mind-bending challenge that could change the course of human history. We've discussed the challenges, the science, and the potential breakthroughs. If you have any thoughts on this idea, please share them in the comments below. What do you think are the biggest challenges we face in harnessing kilonova energy? Thanks for watching, and I'll catch you in the next video where we'll explore more fascinating space phenomena.